Now we have understand the core intuition of a merge sort algorithm, right? Now we have also seen how it works conceptually. Let's go ahead and write some code, or rather I would say, let's write down the pseudo code, right? To understand how to actually implement this merge sort algorithm, right? So we will use the pseudo code from the CLRS textbook, right? As we discussed in the previous video. So this pseudocode will give you the clean and the language independent, and it's very clear in expressing the logic, right? That's why I'm going to use the pseudocode rather than the actual one. So if you look at the merge sort algorithm, we are going to use the two important functions. So the first function, which is the merge sort function, and the another function which is a merge function. Now let's go and understand what are these functions are actually doing in this entire logic, right? Now let's first understand the merge sort function. So if you look at the merge sort function, it takes the three parameters as an input. So A, P and R. Now let's go and understand what are these parameters are. So the A here is the array. So is the input array. So in this case, let's say this is my input array. This array contains total 8 number of elements. Now what about P here? P is the index of the first element of an array, right? So this is the index of the first element to be sorted. Let me write it down here. The index of first element, right? Element to sort. So here I just used ELT, which stands for element. Now what about R? R is the index of the last element to be sorted. So that means the value of P will be 1 and the value of R will be 8 as per the given input array A. So if you take our example array of size 8, the initial call would be what? So the initial call would be something like this, right? So the name of the function is a merge sort, and I'm passing the array A as an input, and the value of P will be what? 1 here, and the value of R will be 8 here, right? So this is the call we are going to make it initially. So here the value of P is 1 and the value of R is equal to 8. So the next important thing inside the function we need to check is this particular condition. So the condition says that P less than R. If this condition satisfied, we need to execute these 4 lines of code, right? So what this condition is doing here? So why do we need to check this condition? So assume that my value of P is equal to R. That means the subarray contains only one single element. So same like this, right? So if P and R is same, that means this subarray contains only one element. And this single element is already sorted, so we don't need to do anything about that, right? So that becomes the termination conditions of this entire process. And by the way, I'm using the recursion concept here. So, right, we have already learned the recursion in C programming, right? So, and not only C, so if you take any programming language like C++ or Java or Python, everywhere you will find a concept called a recursion, right? So here I'm using the recursion. So calling the same function again and again until I reach the condition, right? Now let's move on to the next statement, right? So in this case, 1 is less than 8. This condition is true. That means I need to execute the statement which are present inside this particular if block. Now the first statement inside the if block is this: Q is equal to, and here I'm using the ceil function. So this represent the ceil function, and inside that I just kept the value as P plus R by 2. So what is the value of P? The value of P is 1 and the value of R is 8 by 2, right? I'm applying the ceil. So what is the meaning of, not ceil guys, this is the floor, sorry. Floor means which returns the greatest integer less than or equal to the given value, right? So let me give an example. Let's say I want to apply the floor to this particular value, which is 8.2. So what is the output you are going to get? It will return the value 8, because floor will returns the greatest integer less than or equal to this particular value. So in this case, you will get an output as 8. Let me give you one more example. I want to apply a floor function on this particular value, which is 8.9. So again, you will get an output as 8 here, right? So whenever you apply the floor function, floor always returns the greatest integer less than or equal to the given value. So that is the meaning of floor here. Similarly, we have the ceil function as well. Now let me show you with an example what the ceil function is doing. So let's say I want to find the ceil of 8.2. So I'm using this notation for the ceil function. And this function will return the greatest integer greater than or equal to the given value. So in this case, the greater than or equal to the given value will be equal to 9. Right? So that is the meaning of floor and ceil. So as per the given example, my value of q will be what? P plus r, 1 plus 8 by 2. I'm applying the floor function. So in this case, floor of 9 by 2, which returns 4, right? 9 by 2 will be 4.5 and it will return the value 4 here. Now the value of q is equal to 4, right? Now the next step here is I'm calling the same function again, right? By passing the value or passing the input values are the input array A and the value of P. So in this case, the value of P is 1 and the value of Q is 4 here. That means I'm dividing the given array into two subparts, right? So I'm calling this function by passing the value as A comma 1 comma 4. Initially, I called the function with the values are 1 comma 8. Now I divided into two parts. And the next recursive function call is making it as passing the values as A comma 5 comma 8. So that means literally we are dividing the array into two equal parts, right? So I'm calling this function 1 comma 8, A comma 1 comma 8, and here A comma 1 comma 4, and here A comma 5 comma 8. Now again I will repeat the steps, right? So when I call this function, again I will go and check the condition. So here P and R are 1 comma 4. I will check the condition. If this condition satisfied, first compute the Q value. So Q will be what? 1 plus 4 by 2. So which will return, I'm applying this floor to this number. You will get the values 2 here, right? Now again I'm going to call this function A comma 1 comma 2 and here A comma 3 comma 4, right? So I'm going to repeat the same steps until I reach the sub array of size 1. That is what we have seen it as part of that intuition, right? So at this particular point, the value of P and R will be same. So P equal to R. Then I will stop this process, right? This condition will get failed. I will come out of this and I will go back to the previous recursion call. So if you look at the overall scenario, what this recursion is doing, it keeps dividing the array into smaller and smaller sub arrays until I reach the array of size 1 here, until I reach the array of size 1. So this is the divide step, which we have already discussed as part of the intuition, right? Now let's come to the important part of this algorithm, which is the merge function, right? So the merge function is responsible for combining the two sorted subarrays, right? So we will go to the next step of this algorithm, that is the conquer or the merge step, right? Notice that my merge sort algorithm or the merge sort function, after the two recursive calls, we have A comma P comma Q comma R. This is the merge function. So the sub array, this is my sub array E. So I'm just taking this as an example, right? From E, P to Q from 1 to 4, and the sub array from 5 to 8, right? Each is already sorted. Now we need to merge them into a single sorted array. So the recursion performs the divide step and the merge performs the conquer or the merge step. So this is the classic example of recursion and the divide and conquer strategy. Now let's go and understand how merge algorithm works, right? So now if you look at this, is the screenshot I taken from the CLRS textbook again, right? And if you look at the function merge, it takes the 4 values as an input. So the first value is A, which is my given array. then we have P, Q and R, right? So it takes the array A and it says that we want to merge the portion of the array from P to R. Let's say this is my index P and this is my index R. Now somewhere in between we have a Q. Let's say this is my Q index. Now if you look at the code, what are we passing to the merge function? We are saying that the given array A from index P to R, we have already divided them into two parts. One part which is P to Q and another part is from Q plus 1 to R, right? That's what we are doing, right? From P to Q and Q plus 1 to R. Once these two parts are already sorted, because of the merge sort keeps calling itself recursively, right? So we need to merge them back together. When we merge them, right? So merge the entire portion from P to R, right? But to do that, we must know that the split point Q here. So now the merge function, we pass the four parameters A, P, Q, R. Now let's understand how merge function works here. Note that the P does not have to be always 1. For example, if you look at here, if you look at this example, here these are my indices 1, 2, 3, 4, 5, 6, 7, 8, right? So my value of P could be 3 here, right? It need not be always 1, right? If you are merging the elements at an indices 3 and 4, the P will be 3 and R will be 4. And what about Q here? The Q will be 3 plus 4 by 2. Floor of 3 plus 4 by 2, which is equal to 3 again. So it works for any sub-array. It's not only for the whole array. Now let's take a full example to understand, make it clear. So I'm taking this as the entire sub-arrays from index 1 to 4 and from index 5 to 8. So these are the two sub-arrays I have. And this sub-arrays is already sorted, right? And assume that my left sub-array contains the elements are 1, 3, 5, 6. And the right array contains the elements are 2, 4, 7, 8. Right? So these two sub-arrays is already sorted. Now we want to merge both of them. So we are trying to call a function, right? So the function here is A, comma, 1, comma, what is the value of Q, which is 4, and the value of R will be 8. So I'm calling the merge function like this. Now look at the line number 1. So the line number 1 says that, I'm counting the number of elements in my left array, right? So in this case, value of Q is 4 minus the value of P is 1 plus 1. That means now my value of N1 is equal to 4 and N2 will also be 4 here, right? And by the way, they do not always have to be equal, but in this example, both arrays are of size 4. Now create, if you look at, right, the third line is the comment line. So what you have to do, you have to create the new sub arrays. Let's say the new array, call it as the L, and our left array of size 4 and the right array of size 4. So if you look at these two lines of code, 4 and 5, I am iterating the loop from 1 to N1. N1 here is what? 4 and N2 is equal to 4. Right? So I'm copying one by one element from the actual array into the left sub array. So this is my left sub array and this is my right sub array. I'm copying all of these elements. If you look at the line number 6 and 7, I'm copying all the elements from array into my right sub array. So this is my L and this is my R array, right? Now, now the next important step here is line number 8 and 9 says that we should add infinity to the end of this array, right? As we discussed in the last video, right? So this is just act as the hypothetical value or the sentinel value. So here we added infinity to the end of both the arrays. Now the next step here is we are initializing the two variables I and j, and I is pointing here and j is pointing here. Now comes to the main loop. So this is my main loop. which runs from K 1 to R. So the value of P is 1 and the value of R is 8 here, 1 to 8. Now I will compare Li with Rj, right? If this condition is satisfied, so that means 1 is less than or equal to 2. So I'm going to place the smallest array, so smallest element in my actual array, that is A. So A of K, which is equal to 1, A of K is equal to Li, the value present at the ith index in my left array. So 1 will be placed here, right? Then what I'm going to do, I'm going to increment the value of I by 1. This is what we discussed in the last video, right? While I was discussing about the intuition, right? Again, I'm going to compare Li with Rj. So in this case, this value is smaller than this. Now I'm going to copy this element into my actual array and increment the value of j by 1, right? So this is exactly we saw in the intuitive explanation, right? We compare the current elements, copy the smaller one and incrementing the corresponding index and repeat the same process. You might wonder, why are we creating this new array L and R instead of using the same array A? So the reason is that while merging the elements or merging the subarrays, the original elements in array may get overwritten. So if you overwrite them before comparing, we could lose the data. So that is the reason first we need to copy the entire sub array into a temporary arrays like L and R, and then carefully merge them back to into my original array A. So that is what we are trying to do here. Now look at the overall algorithm, right? So the merge sort function, the recursive function, checks the termination condition. So this is the termination condition, P is less than R. Then it will divide the array into smaller parts, and it keeps on dividing until we have the subarrays of size 1. Then we have the merge function. So this function is combining the two subarrays. So it takes the two sorted subarrays and copies them into a temporary arrays like L and R, and it compares the elements one by one and places the smallest element back to my original array. So that is what we are literally doing here, right? So the recursion keeps breaking the array into smaller subparts. Once we reach the arrays of size 1, we cannot divide further, then the recursion starts unwinding, right? The smaller pairs will get merged here, right? So once we have the single element, so these elements will get merged. Those merged results get merged again. So if you look at, so array of size 1, then we have array of size 2, then it becomes array of size 4. Finally, we have the two large offs get merged into the single array, single sorted array. So the merge sort function is a short, right? So if you look at this code, literally 5 lines of code I have, right? But the most important function is the merge function, right? So it does the actual work of combining the two sub arrays or the two sorted sub arrays into the single sorted array. The steps are very simple, right? So if you look at the entire merge sort or the merge function, it computes the sizes of the two sub arrays. Then we create the two sub arrays, left array and the right array, and initialize the two variables I and j. I is pointing to the first element of my left subarray and j is pointing to the first element of the right subarray. Then what we have done, we added infinity at the end of these two arrays. Now the main important logic comes here, from k is equal to 1 to 8 here, or p to r. So I'm going to repeatedly copy the smallest element into the actual array A and increment the index corresponding to the smaller element. That's all, right? That's all it is. And later we will also analyze how much time it takes and how much space it will take for the entire algorithm. In the next couple of videos, we'll understand the time and the space complexity of this algorithm.